Lesson 9 is going to be on electron orbital drawings. So we're going to talk about sublevels of the periodic table, rules for electron orbitals, and then drawing out these orbital diagrams. So pause the video for a second, take out your reference tables, your periodic table, and just write S, P, D, F for the color coordinated spots on the periodic table to the right. Okay, so there are 4 energy sublevels on the periodic table. They're called S block, P block, D block, and F block. These represent different locations where electrons can occupy.
So of the 4 different sublevels, we're going to start with the S sublevel. In the S category, we start at the 1s position, and the S block only holds 2 electrons. In the P block, we start at 2p, and the P block can only hold 6 electrons. The D block starts at 3d and holds 10 electrons, and the F block starts at 4f and contains 14 electrons. So when I was saying before that the S block holds 2, if you notice, there's only 2 places to the left, to the right in the S block category, while in the D block you have 10 places, while in the P block you have 6 places from left to right, and you have 14 places from left to right in the F block. So again, let's go over this. In the first principal energy level, or the 1s category, you'll notice that these are the only 2 elements, hydrogen and helium. I've moved helium all the way over to the left-hand side where it should be. So you're noticing that there's only 2 spots or 2 electrons can be held there. Now you're going down to the second energy level, and you're noticing you have a 2s and a 2p. And if you count all the places, that is 8 electrons that it holds. For 3s to 3d to 3p, that's a sum of 2, 10, and 6, giving you 18 electrons. For the fourth energy level, you'll notice you have 2, 10, 6, and 14. Thus, you can hold 32 electrons in the fourth energy level. Same thing for the fifth energy level. But when you go down to the 6, you'll notice you only have a 6s, a 6d, and a 6p, thus 18 electrons. And finally, for the 7s and 7p, you can hold 8 electrons.
So off-Bose rule, it's German for building upwards. Electron configurations always begin with the 1s sublevel because we have to start with the lowest possible energy for electrons. And again, the closer you are to the nucleus, the less energy you have.
When we do electron configurations, it's kind of like a game, like a board game. You always have to start at the start. And the start, at this case, is always 1s, which is hydrogen.
So now Pollys Principle, only 2 electrons per orbital is allowed. So in Pollys Principle, you're going to draw these SPs, Ds, and Fs as boxes representing levels, and then you're going to occupy them with 2 electrons using arrows.
So if you're noticing that little chart on the right-hand side, that's a great thing that you should be copying down into your notes as well, because the S block has 1 orbital, the P block has 3, D block has 5, and the F block is 7.
And that represents how many boxes we're going to draw.
Exactly. And if you pay very close attention, because it says only 2 electrons per orbital, if you multiply all those numbers by 2, you're going to get the same number of electrons that we just covered. So looking at the very top left, we have lithium and beryllium. You'll notice that there is 1 box because those 2 electrons can be fit into 1 box, because that's part of his rule. In the P block, you have 6 different boxes, or 6 electrons, but divide that by 2, you have 3 boxes. The D block, you should have 5 boxes. For the D block, wow, I can't say this word today. For the D block, you should have 5 boxes, and for the F block, you have 7 boxes. Again, if you multiply those numbers by 2, you'll get the right amount of electrons per block.
So the last rule that we have to talk about is Hund's rule. Hund's rule states that 1 electron per orbital before pairing. So you can only put 1 electron facing upwards, or 2 electrons, 1 upward arrow and 1 downward arrow. And again, in each orbital, you can only fit a maximum of 2 electrons.
So when we're making these orbital diagrams, you first off have to locate the element on the periodic table and identify the sublevel block that it occupies. Then you have to determine the amount of electrons it has, which is the atomic number. That also indicates the amount of arrows you'll be drawing. Then using the 3 different rules, Aufbau's, Pauli's, and Hund's rule, you're going to be adding the arrows. So we're going to do the first one together. Helium is the second element on the periodic table and only occupies the 1s orbital. So therefore, you would be using 2 arrows, because it has 2 electrons, to occupy the very first box, which is why we draw it as an up and a down arrow. Okay? For the next one, you have beryllium. Beryllium is going to be the 4th element and is part of the 2s block. Therefore, it has 4 electrons or 4 arrows, so you should have an up-down arrow configuration. For nitrogen, which is also in the second principal energy level but is in the p block, it is going to have 7 electrons. Therefore, there'll be 7 arrows. And in this method, you will notice now that the first 2 blocks are full with the up-down arrows. But in the p block, they're all facing upwards. This is what we call Hund's rule. The electrons have to be all upward in an orbital before you can start putting the downward spin arrows. And finally, for neon, which is a 2p element, it contains the maximum amount of electrons because it is a noble gas. And you'll see that there are 10 electrons for the 10th element on the periodic table.